a blank page, a list of precise measurements, and a set of intersecting spatial rules. Constructing a geometric map from a written word problem can look like an intimidating puzzle at first glance. Welcome back to Scholars Academy. Today, we are tackling a classic 4-mark exam challenge and breaking the construction down step by step. To solve this, we are leaving the protractor behind. Our only tools for this entire map will be a standard ruler, a sharp pencil, and a drawing compass. Our prompts construct the boundaries of a park. First, we must apply the scale. 10 meters in the real world equals 1 centimeter on the page. That means our park's 50 and 63-meter boundaries drop down to workable 5 and 6.3 centimeter lines. In addition, we have 2 strict constraints: building specific angles and applying locust rules to place perfectly equidistant features. Earning full marks requires taking these raw text constraints and translating them into an exact, verifiable geometric proof on your paper. Let's start drawing. We begin by building the foundation. Use your ruler to draw a perfectly straight line exactly 5 centimeters long. Label the left endpoint A and the right endpoint B. Next, the prompt requires a 75-degree angle originating from point B. Without a protractor, we have to derive this angle using compass bisections. Place your compass needle on point B and draw a semicircle. Keep that exact same width, move the needle to where your semicircle intersects the baseline, and strike your first arc. That marks 60 degrees. Move your needle to that new mark, strike a second arc, and you have 120 degrees. To find 90 degrees, simply draw intersecting arcs high above the baseline to bisect the space right between those 60 and 120 degree marks. Now for the final step. 75 sits exactly halfway between 60 and 90. By placing your compass on the 60-degree arc and the 90-degree line, you draw 2 final intersecting arcs. The line that perfectly splits that gap gives you exactly 75 degrees. Take your ruler and extend a straight line from point B straight through that final intersection. Measure it to exactly 6.3 centimeters and mark the end as point C. Compounding these basic bisections is the only valid way to derive precise, non-standard angles and secure your exam credit. Now we need to locate the 4th corner of our park, point D. The prompt states that D must be equidistant from boundary lines AB and BC. When you need to find a path equidistant from 2 intersecting lines, the geometric solution is an angle bisector. So we place our compass back at point B and bisect that 75-degree angle we just built. To close the shape, the prompt specifies that angle A is exactly 90 degrees. We repeat our earlier 90-degree construction process, this time centering the compass at point A. Draw a straight vertical line starting from A, through your new 90-degree mark, and extend it straight up until it crashes right into the angle bisector we drew from point B. That exact point of intersection is point D. To seal the park's perimeter, simply connect point D across to point C. Loci are simply spatial rule sets. When you map 2 different geometric rules on the same page, the exact coordinate where they collide pinpoints your required boundary. The perimeter is complete, but we have one final task. The prompt requires us to locate a flag post, point P, along a line connecting B and D, such that it is entirely equidistant from corner points A and B. Here is our second locus rule. To trace a path equidistant from 2 specific points, you must create a perpendicular bisector between them. Place your compass needle at point A. Open the arms so the width spans visually slightly more than half the length of line AB. Strike an arc high above the baseline and another directly below it. Without changing the compass width, move the needle to point B and sweep a second set of arcs so they intersect the first pair. Draw a clean, solid line connecting that top arc intersection straight down to the bottom intersection. Follow this new perpendicular line to where it crosses the internal path between B and D. That exact crossing marks point P, the location of our flagpost. Successfully layering multiple distinct locus rules onto a single diagram is how you prove your geometric comprehension to the examiner. Take a look at the final drafted map. The geometry is dense, but every construction arc serves a clear, logical purpose. Let's verify our diagram against the original text prompt. We properly translated the scale for our 5 centimeter baseline and our 6.3 centimeter sidewall. We correctly derived a 75-degree angle without a protractor, and we satisfied the first locus rule by using an angle bisector to pinpoint point D. And finally, our perpendicular bisector successfully anchored the flag post precisely where the second locus rule demanded. If this walkthrough cleared up your locus and construction questions, make sure to subscribe to Scholars Academy for more step-by-step exam solutions and mind map tutorials. Mastering these ruler and compass logic rules guarantees you the ability to turn confusing word problems into undeniable geometric proof.